Okay, so let's start on this particular stoichiometry set of problems. All right. So, first of all, what you want to know is if you're doing a unit conversion, you're going to use one of these three things right here, either grams if you're going from or to grams, liters if you're going to and from liters, or particles if you're going to or from particles. If you're doing a compound conversion, which means from one compound to another, you're going to use the balanced equation. Okay. So let's get to it. And here we go. So if we have this balanced equation right here, and it is balanced, if 0.816 liters of oxygen are reacted at standard temperature and pressure, how many moles of C25H52 will also be reacted? So basically, we're talking about starting here and how much of these are also going to be reacted, okay? So here's how we work this. We're going to start out with, first of all, we're going to write our given, 0.816 liters of O2. Then we're going to check and make sure that our equation is balanced. So there's numbers in front of it. I've got 76 oxygens, and I've got 50 plus 26 is 76. I've got 25 carbons and 25 carbons, and I've got 52 hydrogens, and 26 times 2 are 52 hydrogens. So it is a balanced equation, which is really important to have. Now, what I want to do is is it in moles? So I'm going to look at it and say, is this in moles? No, this is in liters. So when I'm doing stoichiometry, the first thing I have to do is make sure I put it in moles. So I'm going to come up here and do a unit conversion. That unit conversion is taking it out of liters, whatever is right here, I'm then going to write down here, and I'm going to put it into 1 mole of O2. And you can see 22.4 liters is what we're using, is 1 mole of O2. I will cancel those out. I have now converted it to moles instead of liters. Now, my next question is, are there two different compounds in the problem? Well, I start with O2, and I'm going to end with this hydrocarbon. So yes, that is the case. So I'm going to take it from mole O2 to mole C25H52. Okay? So I'm now doing a compound conversion. And in this case, I'm using what's called the mole ratio from the balanced equation. Okay? And I'm going to take the number from in front of that is 38 in front of the oxygen. And there is a 1, even though there's nothing there, there's a 1 in front of that hydrocarbon. And that part is done. Now, the next question is our answer in moles? We are looking for answer in moles. And in this case, we are looking for answer in moles. So we have finished setting up this particular problem. Now, all we have to do is we have to complete it. So I'm going to do 0.816 times 1 times 1. Those are the top numbers. And I'm going to do 22.4 times 38. And it's 0.816 times 1 times 1 is 0.816. And 22.4 times 38, and that's going to give me 851.2 for the bottom part of it. Now, to figure out how many moles that is, I'm going to do 0.816 divided by 851.2, and that's going to give me 0.0009586 mole C25H52. Now, if I want to make that neat, first of all, I've got 3 significant digits here and 3 here. So I'm going to chop it at 3, and I'm going to move that back 1, 2, 3, 4. And my nice, neat answer is 9.58 times 10 to the negative 4 mole C25 H52. Now, it would have been just easy enough to just leave it like that and raise that up to a 9. But that is my final answer for this problem. Okay? And I only needed 3 for that. Make sure you cross everything out. You've got a point here. You got a point here. You got a point for crossing out. You've got the point for the correct answer. And then there's your units and your compound. And that is the first question. The next one we have, so make sure it's a balanced equation. So we've got 2 arsenic, 2 arsenic. We've got 6 and 6 sodium. We've got an O and an O, 6 O's, 2 times 3, and 6 H's, 3 times 2. So we have a balanced equation now. So we're going to start with our given, 43.4 mole H2. Now the question is it in something, is it in mole? If it already starts in mole, I don't have to convert to mole because it's already there. So now what I'm going to do is is it in a different one? So I'm starting with H2, which is right here, and I'm going to end with this one right here, which means it's 2 different compounds. So I'm going to go from mole H2 to mole Na3 ASO3. So I'm doing this is what's called the compound conversion. I'm converting compounds, not units in this case. All right, and the number in front of the H2 is 3, and the number in front of the sodium is 2. And then I'm going to cancel out because I have now successfully gone from moles of hydrogen to moles of sodium arsenate. Okay? Now I'm going to look and say, okay, I want grams in that. So I need to get out of grams. My final answer is not in moles. My final answer is in grams. So I need to do a unit conversion here. And I know that I'm in moles, so 1 mole in a unit conversion is always 1 mole of whatever you're doing, ASO3. And now I'm going to look for grams of NaASO3. Okay? And the way I find that is I have to do the Na, 2 of them, 3 of them. I have to do arsenic, and I have to do oxygen times 3. I know that Na is 22.9 times 3, and that's 22.9 times 3, and that's going to give me 68.7. And I know this one is 48.00 because it's 16 times 3. Arsenic is look at my periodic table here. Arsenic is 74.92. 74.92. So then I'm going to add all of those up, and I've got 68.7 plus 74.92 plus 48, and I get 191.62. So that goes 191.62 for the grams of arsenic per mole. And I'm going to now cancel out because I have now successfully converted from moles to grams. Now all I do is I'm going to multiply across, which is 43.4 times 2 times 191.62. And I'm going to divide the 3. And I get 5,544 grams NaASO3. 3ASO3. And that's going to be my answer. But if I want the one that's going to get me the gold, I've got 5540 because I've got 3 significant digits here. This one has 5, so my answer has to stop at 3 significant digits. So that would be my answer there. And I've got that, I've got that, I've got that done. I've canceled out, and then I've put my answer down here. And that's the second one. All right, let's look at the third one now. The third one is particles to grams of O2. Okay, so first of all, I have my balanced equation here. The numbers in front of it tell me it's already balanced. So I'm going to start with my givens, 6.43 times 10 to the 24th particles of CO2. And since I'm starting in something other than moles, I have to get it to moles first. So in order to do that, I've got to do it by Avogadro's number times 10 to the 23rd particles CO2. That is from right up here at the top where I have this particular conversion right here. This is a unit conversion. Unit conversion. And it's 1 mole. It's always in a unit conversion. It's always 1 mole of whatever you're doing. Now I have successfully completed the conversion from particles to moles of CO2. Now the next question is, are 2 different compounds involved? And yes, we have carbon dioxide and oxygen involved. So I'm going to change it from mole carbon dioxide to mole O2. And in this case, I'm going to use the mole ratio. And the mole ratio is going to come from up here in the balanced equation. The number in front of oxygen is 9, and the number in front of CO2 is carbon dioxide is 7. So now I have completed my conversion from moles of CO2 to moles of oxygen. Now, is my final answer in moles? No, it is not. So now I have to do one more unit conversion from moles to grams. And I know O2 is 32.00 grams. So it's 16 each oxygen times 2 is 32. So 32 grams O2. And now I have successfully converted out of moles of oxygen into grams. And in this case, the only thing I have left to do is to wrap it all up, tie it in a bow, and put it in my calculator here. So the way I do this is I'm going to separate out the exponents and the decimal numbers. So I'm just going to do the decimal numbers first. 6.43 times 9 times 32, and I'm going to divide out 6.02, and then I'm also going to divide out 7. And right now I get 43.94. I'm going to see if that sticks. I'm going to do it one more time just to make sure. So I've got 6.43 times 9 times 32 divided by 6.02 divided by 7. And I get 43.94 times 10. Remember, I've got those exponents to take care of. In this case, I've got 10 to the 24 over 10 to the 23. So that makes it 10 to the first. And there's a couple ways I can go with this. I can move my decimal point over 1 and add 1 here, make it 4.394 times 10 to the second. I can just multiply it by and make it 439.4. Either one of those answers is correct, and it would be grams oxygen. And if I want the full credit or the extra, then I'm going to put it in 3 significant numbers, which is 439 for this one. Okay? So that's the answer to that one, is 439 grams of O2. Now the last one I have here, I have a balanced equation already. And in this case, I'm going to start with my given 5.517 mole AlOH3. And do I need to convert to moles? No, it's already in moles. Do I have another compound I'm working with? Yes, I have CH4 that I'm working with, so I need to change it from aluminum hydroxide to methane. And so I'm going to put mole, whatever's here, mole aluminum hydroxide, and I'm going to change that to mole methane right here. And then I'm going to look up here at the balanced equation, and I see that there's for every 4 moles of aluminum hydroxide, I'm going to get 3 moles, also get 3 moles of methane. So it's 3/4. I have now successfully converted from aluminum hydroxide to methane. And now, is my final answer, do I want it in moles? And the answer is yes. So literally, that's all I have to do. In this case, I'm just going to now 5.517 times 3 divided by 4. And my first time putting that in the calculator comes up with 4.13775. Let me make sure that's true, because you never just want to believe it. So 5.517 times 3 divided by 4, and it's 4. Yes, so I get a verification on that, and it will be mole CH4. So that would be the answer that would come up from my calculator. If, because this has 4 significant digits, my answer would have to be in 4 significant digits to be absolutely correct, and that would be 4.138, and it would be moles of methane. So for those of you who have questions of how many brackets do I use in this, it depends on the question, what it's asking, what it gives you, and what you're going to. When I'm going moles to moles, I only need 2. So I just need the mole and the mole ratio. That's what this is. And that's it. If I'm going from, let's look at these two, either one of the units other than moles to moles, I only need 3 of them, because I need to get to moles and then out. In this one right here, I start with moles and I need to go out. So I need to convert moles and then go to whatever I'm going to. In the one that has the biggest is 4, I'm going from one type of unit, particles in this case, to another type of unit, which is grams in that case. So it really depends on the question you have. All right. I hope this helped. If it did help, tell a friend, send them the link. I appreciate it. And I hope this helped.